7 years ago, and the business is to design and develop small powerboats, ribs in particular, ranging from 7 to 10 meters at the moment. Brian has been designing hulls and ribs and producing hulls and ribs for 24 years. We came into this project, Island Ribs, with a view to continue Brian's previous work and to refine it further with a view to building boats that are compliant, not just to the RCD, because that's quite a simple process to achieve, but to design boats designed to comply to MCA coding standards. So what do? We design our hulls and our boats in-house. We build our tooling in-house, and we market and sell our product in-house as well. Would you mind clicking through on these? How do I? Click the down button. Thank you. Perfect. So I just put a couple of quick photos together. Actually, out of our. Where am I pointing this, please? No. Thrown a few very quick photos together as a starting point, just to try and get conversation going. This is one of Brian's early boats. It's a 6.5 meter boat. I believe it's got a 90 horsepower engine. It's in the Irish Sea, 4 blokes, all facing forwards, no goggles, no windscreen, traveling at about 30 knots. The key point being the trim of the boat. That's what's going to keep them safe, not the life raft that they aren't carrying. Next, please. So we've kept Brian's designs current. This is a new design, but very similar to the boat we just saw. This boat we completed towards the middle of this year. It's a diesel inboard vessel. It's slightly larger and wider than the boat that we've previously seen, but still the boat trims true, travels in a comfortable attitude. That one's MCA 3R for 8 passengers. Could you click on to the next, please? This is slightly out of proportion. They're both 7.5 meter ribs. This is an outboard version, went on to be coded. It's somewhere between commercial and recreational, although it's coded. It's used by a classic yacht as a tow vessel. However, they still code it on the basis that many of the people that get on and off that boat maybe aren't paying, but it gets into that grey area. Just clicking on through, please. The 3 photos, the last, this one, and the next one, Brian and I went out on a couple of boats with a photographer just to catch some photos. So that's the same boat on the same day as we've just seen, just turning, ready to come back through to take a couple of extra photographs. Just clicking on one more photo, please. And that's 15 minutes later. Looks like it's an offshore photograph. If you look closely, this tree line here is West Cowes. The Royal Yacht Squadron is somewhere between Brian's knees, just on the other side of the boat. We're 200 meters offshore in Cowes Roads. Offshore, sorry, off the beach in Cowes Roads. On a particularly calm day, actually, not calm. It wasn't anything dramatic. It's a properly tidal bit of water. So the point being, where we're kind of coming from, that there's so much more to this than just the equipment that you put on the boat and how that boat is running. That if surveying becomes or signing off a vessel in whatever level you're doing that, whether that be as a recreational product or a coded vessel, if you move towards it being a box ticking exercise of how many life jackets and how have you got a life raft, the problem comes that there's so much more that's relevant. Is the boat seaworthy? Is it safe? And those factors are quite hard to govern in a box ticking exercise. Personally, having spent a lot of time at sea, the life raft I'm not actually that bothered about in the first instance. I want to know, is this boat seaworthy? Is it going to keep me safe? And that's more about the hull, the process, the boat being trimmed correctly, set properly, and that those processes further down the line shouldn't govern the primary function. We design and develop the boat in-house, so we know how it's built. We understand the structures that are within it, and we know how different the structures are in a small power boat like this in comparison to other vessels that are out and about. A rib obviously has tubes, armbands if you like. Why does it have armbands? Well, not just to keep you afloat. The other reason is to take the weight out of the vessel, to lift the tube high out of the water, to give you decent protection from the water, to put you low down in the boat. All of these small factors, where the hull joins the deck, has a fundamental change in how that structure works. And yet that is not covered in much of the Scantling assessment that we have to go through in order to make a boat compliant. So I'm kind of looking for someone else to have a go at talking.
Yeah, no, I mean, Brian had it anyway. I was born and bred on a boat, on Hamble River, on a steel motor vessel. Trained as a shipwright, did some extra work in design after that. Went to British Aerospace, became an aircraft engineer, and then decided I was going to start building ribs back in '96. And of course, back then things were a lot different than they are now. There's a myriad of extra boats that have been built since then, different makes, manufacturers. That I perceive that there's no guarantee of the way that a vessel's been built. Once you've got a closed deck, monocoque, anything could be going on below that. You're really reliant upon the quality of the build in the first instance. And I think that's my biggest thing that I take from the whole RCD, MCA, and the coding process, is that actually you can go on board a boat, have a look, it's shiny, it's clean, it's got the right safety gear on it, and you go, yes, I'll tick that, that's good. But there's no guarantee of the structure of the craft itself, the way the tubes are bonded to the craft, the way the craft is built, and the inside structure is protected from the elements. I don't know how many of you guys use ribs, but certainly I'm sure many of you have been on them that have been full of water. And they seem to spend a lot of their life with the internal compartments with a good proportion of water in them, seawater, foul water, whatever you want to call it. And of course, that's not conducive to keeping any kind of GRP structure in good order. So I would say that that's probably where I come from with regard to the structure. Right from day one, I think we have some pictures of our internal structure.
Yeah. So they'll roll through.
Yeah. There's not. Yeah, absolutely. Yeah, yeah. Yeah, no, I'd rather have a discussion. I think the one thing I don't want to do is be that arrogant and stand in a room of surveyors and tell you all about how good or bad you are.
Just so that the guys online, because they won't be able to hear your question, can you repeat the question back when you asked?
Okay, yep, go on, yep.
I agree entirely with what you were saying about there are a lot of factors and it applies particularly to ribs in some ways, it applies to other boats too, in terms of the condition of the vessel, the way it's set up, all the rest of it are vitally important. Depends what it is doing with it. Depends whether it's doing whether it's 200 yards off the coast or whether it's out the North Sea. If it's jumping about in big waves, it's got more load and stress on the structure than if it's running about from harbour to a yacht or something. But the way it is maintained, looked after, set up is important. How that gets translated into coding is difficult because the code is full of detail about stability. It's full of detail about how structures, in theory, might be. The could hear it.
No,
So
well, I'll stand here and
it's full
you
of
carry on.
it's full of detail about how structures, in theory, should be assessed. What rules and regulations should be used to assess structures. There is almost nothing in the codes. 2 paragraphs, 3.1.4 or something, and 27.7.2 in MGN 280 talk about the requirement for the vessel to be maintained in good condition. In most of the SCV2 report forms, there is one tick box page where the surveyor ticks a bunch of boxes and says, yes, this, that, and the other part of the boat are in good condition. How the hell on a rib do you decide that the vessel's in good condition, either as regards its structure, which you can't see under the deck, but also some of the things you're talking about to do with the way the boat's set up, to do with LCG, to do with whether engines have been changed or not. So I wonder, I mean, I imagine if you're designing the boats inside,
Yep.
where the LCG is pretty important to you.
Absolutely, yes.
And if somebody therefore puts a different size engine on the back, or all those sort of things, I don't know if you want to talk a bit more about things like that.
That sort of is
important.
covered. So the changing of the engine and the modification, let's call it, by the end user is sort of covered. Certainly from a perspective of our warranty, let's say, for example, if someone comes along and puts a 300 horsepower on a boat that is only designed to take a 200. Then that is the onus of that, I believe, is on the end user, not so much on the builder.
I think Fraser's brought us right to the very point that we want to bring along from the outset.
Yeah.
You can't do anything that Fraser has asked if you don't speak to Brian and Alex. We produce a process, a procedure by which we build our boats. We know how much product and resin will go in, and we know the detail of how our fabrics and our materials are used in order to ensure that they are watertight, integral, structurally used in the right places, in the right process. And we also know what to look for in terms of maintenance. You guys can look at the top and you might see some fracturing in some white gel coat, but you wouldn't understand necessarily, as we would, with a production run of vessels, where that fracturing is caused and why it's occurring. We might be referring to you for some of that assistance, but the point being, we have the history, we have the procedure, we have the log of the materials used. We know where the longitudinal center of gravity needs to stick. And as soon as that small product moves away from its manufacturing core and becomes out in the white van routine where people may modify and improve, inverted commas, then you move into a difficult area. Just shifting the weight forwards into the foredeck would have an effect on how the boat performs. So unless perhaps we have a system more like, dare I say it, an MOT, a routine of inspection, then actually we've got a problem.
I think also the standard of build necessary at the beginning isn't, okay, in that situation, we're happy with what we produced and we make sure that the standard is great. But we're probably, there's a lot of other people that aren't necessarily going to be doing that. They're more about building the product and getting it on the market and getting it sold and forgetting about how badly they built it in the first instance.
The surveyor's opportunity is to look inside the boat during build.
I think the reality is that this is going back to what you were just saying about some kind of legislation. Actually, you need that right at the beginning when the boat is built to make sure that that is built to a good standard and it is built to a specification, not after it's put together as a finished item, which you can't inspect, and then just put a category C CE plate on it and say, that's great, it's safe, you know. Okay, it's safer inshore waters. Well, as we've proven with this photograph, not that one, the one before, is that actually the inshore waters aren't necessarily a safe place to operate a craft that's not built well. You know, we can just as much get into trouble in the Solent as we can in the Channel or in the Irish Sea. You know, it's still, in my view, a big issue is the way that the boats are manufactured in the first instance and controlling the quality of that. Was there another question?
Yeah.
Yeah, I'll come over this way.
Can we just back up the truck a bit? So I can fully understand what you're saying as builders is that gives us a good standard of build because you comply to that system. The MCA say to us as surveyors, you can put the RCD, you've got an RCD and it tells you the weight ratio and how many people it can take. And we do certain in-house tests, such as defleeting one side and putting all the load on one side, and all these business, all that's laid down in law by the MCA. And then the MCA lay down in law a list of equipment that that boat has to carry, which includes life rafts, a kedge anchor, a main anchor, everything that has to be stored away. Now, what I hear you saying is, oh, you know, you should be a bit careful about running a tick box and saying, oh, they've got to have this, they've got to have that.
No, it's very easy to count. Is the life raft tick?
But isn't that both what we're saying? Is that actually the MCA coding is more about what you're carrying aboard the boat than how good the boat is?
It is.
Yeah.
And we don't have a control over
No,
that.
absolutely, you don't. The only person that has control over that is the person who builds it first.
Exactly. Oh, so we're both saying the
Saying the
same
same
thing.
thing.
Thank God for that. Yeah.
Anyone else? Any more for anyone?
So my point was really that I go on a lot of it, and you know, the owner's saying, well, where am I going to put all this shit then? You want me to have a life raft and you want me to put 2 anchors? And when they're on the foredeck, they're bloody dangerous because every wave I hit, the anchor comes towards me, and you know, and I say, well, that's your problem, not mine.
It's the design.
Exactly.
It's the design. If you don't design the boat to be compliant, to put it bluntly, you're working against the gale. You're going about this the wrong way. We built a prototype boat because that's what you do in production. I come from production engineering. That's what my specialist skill was to bring to this business. I developed projects for JCB, innovative, quite out there projects, and brought them into the marketplace and had a great time doing it. And then I spent a long time at sea and doing some other stuff, and it came full circle round that Brian and I met and got into the idea of getting going with a new rib building company. And I've completely forgotten where I was going with this. Compliance, yes. So we built prototypes, number one. We were pretty confident in the design because I had to go on a few of Brian's previous boats, and I can kind of tell when you're standing on the boat whether or not it works. That was fundamental. I can tell that a big high bow and a nice concave bow form that will crack on through the Solent in some poppily water and keep herself trimmed, and I don't need to work hard to do so. Okay, we're on the right boat. So we built a prototype, and we built this splash well section that you can see here. We build it for many reasons. Number one, stops the water coming in and gathering around your ankles when you slow down quickly. It means you can sit at rest with your transom towards the weather and receive it in the boat with you. It also gives us the opportunity to properly tubes at the back with a structural component holding the tube carrier, and we also get the opportunity to re-strengthen the top of the transom rather than just working from the bottom up. We're containing the whole back end of the boat into a...
And a large storage area for all your bottles of water and life jacket.
Yeah, lots of storage, exactly. So,
and 3.
pardon?
If that thing ships up whole deck full of green water,
Yeah,
how do we into the drain?
exactly
two
like all
trunks.
other ribs. 2 big drain holes in the back with a pair of elephant trunks that you can see clipped here. Look, there's the elephant trunk, just like any other rib. That's how they all drain, unless it's a lifeboat, and then we don't bother building a transom and we just let it all wash out the back along with all the things that you had on the boat before it washed out the back, lines, people, casualties,
exactly.
dogs, etc. So we built a boat without a splash well because we needed to get it in the sea and drive it around the oceans like idiots and see if we could do any damage to it and see how it really performed, because that's the requirement. And we sold that boat with a prototype prefix in the serial number to a customer of Brian's previous company who had previously bought 7 vessels from Brian. So he was pretty happy with what he was buying. And he's not a fly-by-wire kind of chap. So because he happens to do a few miles of work in and around some rivers, we put it under the Tsushima coding. But it has no splash well. It only has that much freeboard across the transom. And the proposal from the surveyor was that we put a piece of fabric across the transom to achieve 250 mil freeboard on the transom. It doesn't make sense. The fundamental point is the coding is clear. 250 mil freeboard at the transom with half the crew on the seats, half the crew outboard, tubes deflated. And what happens is people say, well, that isn't achievable. That can't be done, and the boat works fine. Tick. It's got a life raft. The rules are there. They're there to be adhered to. And if we don't design the rules in the first place, it's very hard to backtrack to do that. But the only way that that can occur is if they get signed off. If we accept RCD Category B as being type testing or approval for a commercially coded vessel, we have a problem because we know how easy it is to get a boat through. Not because it's not incredibly difficult. There isn't actually an analysis of how the deck is bonded. And structures need to be really considered. We use a molded deck in our rooms. This is a brief model that we've been trying to finish for
7 years.
as long as we've been building boats. It shows our hull form very neatly. This is a 1 metre model of a 10 metre vessel, so you're welcome to come and have a nosy, perhaps pass it round. But the hull form is the most critical factor. How big is the bow? How does the water, is it shipped, is it shed? What are we going to do? Go over the tops or go through the tops? All of those factors come into play. But you can see when you look at this, that there's not a lot of boat here. This bit at the back is quite thin and it's carrying it's doing a lot of work. And how that's constructed inside is of paramount importance. That's the really critical bit, isn't it? How this bit works. Slightly off piece together.
Some of the defects that you're kind of mentioning that you've seen in the competitors' boats that we should look out for. You're talking about, you're suggesting that there could be a lot of boats out there which really are structurally.
Well, we can't tell you about how they're necessarily put together internally, but we do know that the cores that you use and the way in which you do it is critical. If we don't encapsulate wooden coring where it's used and prevent water ingressing into it in the future, then we have a great difficulty in talking about longevity. And really, the formers that are used, even the components within the boat, are exactly that. They're formers, they're not structural. Often the bits of material that are used within, if you don't fully form them with structural fabrics, if you simply put a bit of plywood in and put chalk strap against it, yes, it will be strong enough and it will work. But we can't tell you for how long. Why do we build our own boats? Because fixing other people's is a can of worms you don't ever want to get involved in. That surely has to be a story that we all have to consider. If any of you own boats and you've ever taken it into a boatyard, I'm sure it didn't come out with the bill that it went in with. And that's not because all boat builders aren't trustworthy, it's because until you start to open up a monocoque structure, once we put the decks into this and laminate them in, no one else is going back without a chainsaw.
Or an endoscope.
Or an endoscope.
I fully get what you're saying about, in terms of the MCA don't regulate the construction. Looking at it from the other side, I would then ask the question, is there any evidence to suggest that there is a problem out there? So, for example, the RNLI, they gather all their statistics. Do they have a record of, commercially operated ribs breaking up or losing people overboard, or have another,
I think my app have got a reasonable collection of.
I'll say that one, yeah.
That would be the evidence to back up your argument. It'd be interesting to see what.
To some degree, yeah, but I used to sail boats in high latitudes, and I've met Bavarians going around Cape Horn. It's a perfectly suitable boat for certain tasks. People get away with a lot, don't they? I rode a bike, push bike, for many, many years, not wearing a helmet when I was young, and I got away with it. Doesn't mean it was right. And that's what this industry really suffers from. Boat building, marine industry is low volume, bespoke. It's a word I despise. I don't like this boat because there's not enough room for me to put my children in the bow. Could you move the console back, please? A lot of people, a lot of businesses will say, yes, of course. And what we can't have is those vessels coming round the loop and later on, at a later date, coming back into the marketplace as a commercial vessel because we've ticked the boxes and said that will do. The only way that you, as surveyors, can be certain that boat is built correctly is to have conversation with the people that build it, to visit and see. If they can't show you which product they put into that boat on which day, by which volume, to which process, and where the records are kept, then we should be questioning whether or not that's a commercial vessel.
Would you entertain the idea of us bringing a group of surveyors to your
Well,
office?
welcome it, yeah, we'd try and pick you up on a rib and show you. Yeah,
Something for the spring? Okay.
yeah, it's small details. It is all about the small details that make the difference. In a recreational marketplace, if I stand at the boat show and I try and sell boats, what do we talk about? I had some really interesting inquiries this week. A lady said, I need a bench seat for my children because that's where they need to sit, low down at the back. That's not true. That's incorrect. No, you need a boat where the deck is low down so that it's a stable vessel and the crew are constrained within tubes that are nice and high. The crew should be sat in the centre point of gravity longitudinally as far as possible. If you put the helm on the right side so that when the boat is high and dry and the prop torque pushes the boat off to port side, if you've offset the weights the right way round and the V-hull has a better opportunity to land upright into the water rather than on a flat aspect, you're going to have a safer boat that rides well. A shock mitigating seat isn't going to improve that for you. And heading off down these roads of moving away from the simple stuff, what works at sea, simple. Simple at sea is what works. And if you rely upon technology, ask Boeing for the consequences. You know, technology should be an assister, not something that we rely on. Keeping it right back to its basics, building the boat properly, keeping it trimmed and balanced, and having an accountable record of how that's been built and constructed is surely the best route that we could head. And that's what we as builders would most like to achieve, a clear set of instructions. If people tell us that's what you need to do, and we'll come and check that you're doing it properly, that's easy for us. When we don't have a clear set of instructions defined, that becomes more challenging.
Well, the trouble is, the biggest problem for us is that it's not a level playing field. So we spend a lot of hours making these boats to this standard. A lot more than perhaps someone who was making them to a not as good a standard. But obviously when it goes on the market at the boat show, it's perceived to be just as good as a rib. It's got tubes, it's got a front glass bit, it's fine. I think that's our biggest struggle, is that trying to get this across to people, and I'm not saying you guys, because I would say that most surveyors have a good idea of what, you know, what's broken and what will break. But certainly from the perspective of building new craft and putting them into the marketplace, we've got a lot of people who are doing it badly and undercutting us. So, you know, it makes it hard work for us. We would prefer if everyone had the same ideals.
Makes our marketplace quite comfortable. We don't have to rush around building lots and lots and lots. Interestingly, I was just tallying up our last 20 boat sales, and 2/3 are recreational to 1/3 commercial. Because there aren't actually that many truly commercial ribs in use compared to recreational. There is a much bigger marketplace for recreational vessels. But all of the users of our ribs, be they commercial or recreational, have other boats. They own other vessels. They're a little bit more, they're not jumping out and buying the first boat they see. And the real simple stuff is what makes that boat work really, really well. It's not clever technology. It's not about whether we infuse or whether we wet lay. It's about accountability and record keeping and procedure, rather than an autonomous process of guys in a shed throwing together boats and pushing them out the door as quickly as they can. And that if the process is that you're going to buy your hulls from abroad, ship them in boxes and quickly screw engines on and put the seats where they need to be according to the customer's requirement, we've got to be mindful how quickly that can go wrong.
So there we are. We've moved on from the GRP hull, and we're now to another stage, which I'm sure you're all really aware of, and that is fixing the components into the boat and how that can be so easily done wrong, with the wrong materials, so the wrong adhesives, the wrong fixings, the way that they're fixed. In other words, the wrong size, simply the wrong size pilot drill for a screw. They can all end up with a component that you're relying upon to hold on to at sea, and as we all know, the loading on that can be quite severe, and it's held in with 3 screws and a bit of bathroom sealant. You know, that's the next challenge, and that one is for you guys to you can actually see those things. They're not hidden below the deck. So again, there have been instances of hatches and consoles and seats coming out in the runner. I'm sure we've seen this somewhere. There's no realisation on any faces, but certainly I've seen the picture of the seats, the console, and everything going in a different direction to the boat. So these are all challenges that you're going to have to. Well, I'm sure you've already come across.
So are you saying the RCD is not fit for that?
Well, I struggle with that. I mean, I started before the RCD started. I did my initial designs based on the MCA requirements. Stability and everything was done on the MCA requirements. Suddenly the RCD came in, and the stability test itself was half as good, in my view. So yes, I guess I could say yes, it is not fit for purpose. Although it's a lot more detailed and a lot more thought about than it ever was back in those days. So I think it's improved. Of course, what we don't want to stand this right like that. What we don't want to hear really is the chances are we might end up having to follow another list of rules. But hey, that's for the future. But certainly, I think it's better than it was. Is my answer to that one.
With the RCD, do you use 12215 for your structure, or do you just, how do you?
Depends on the boat. So
you self-certify, do you?
No, we don't. Well, I'll tell you what, I'll pass this one across.
All of our boats are category B under the RCD, which means independent notified body for verification.
Right.
I have a brain injury, so you've got 2 hopes for me to recall the ISO numbers, I'm afraid.
Yeah.
But under Scantlings and Structure, it's a tabletop exercise completed by the independent body based on our layup schedules. So we produce a detail of the layup, the spanning distances, materials, and they do a tabletop exercise. So that's quite interesting because, as we've already said, this is a monocoque structure.
Yeah.
Why do we make a molded deck? Well, because it's a balanced layup. We put the gel on the mold, we put structural fabric on the mold, we put the core material on the mold, and then we put the balanced layup, the next equal proportion of structural fabric. So we're using fiberglass as it's designed to be used, not a sheet of plywood with some laminate on top and a bit of gel coat underneath. If the deck isn't stiff, once it's bonded in the hull isn't going to have the rigidity it requires. We don't carry huge amounts of frames and stringers and structure inside this hull. It's not necessary. It's a monocoque structure. It's working in a different manner. Our deck is joined onto the chine. So the deck is bonding to the hull on the underside of the box chine, so we have a true triangulation between the deck, the stringers, and the hull. That is not detailed in the tabletop exercise that is under the RCD, nor do they detail how it's made, nor how it's bonded in. Now, we happen to laminate our decks into our hulls after we've bonded them. But a lot of people join their decks to their hulls on the top of the tube structure, on the top of the flange that is carrying the tubes. So therefore, you've essentially incorporated a rectangle on top of the triangular structure between the stringers, the hull, and the deck. The actual detail of how this is constructed is fundamental to how well that is going to last and how it's going to function. And it's quite easy to make a very heavy boat that will be stiff until it works. Even down to the simple principles of how we lay the fabric through the boat. Could you click on to just another couple of, this one's fine for now. So we're laying the cloth through the hull. After gelling, we've filled the stringers with their structural fabrics and fillers and overlaid the spray rails. So our spray rails are built into the hull, obviously, but we lay the spray rails after the first chops with some fabric, structural fabric, and fill the spray rails. But what you'll notice is that the biaxials that are running through this hull are overlapping here, look. This biaxial cloth that is laying in the hull is running longitudinally through the boat, not transverse. So all of our overlap is through the keel. There's a number of biaxial layers. Could we click on one more, please? And then once we've reached this process, you can see here the spray rails are still visible, but they've kind of vanished under the layup. It's because they've been filled and incorporated quite quickly. And this bit that you can see in here now, this is a hull laid, partially laid, without any stringers formed. And the tool that you see here is the jig that we use to suspend our stringer formers into the hull. Click on one more, please. These are quite old photographs. This is stage one of the structure layup. Comes in stages because of the way that we have to put in stringers first, fully encapsulate and structurally lay them, and then the bulkheads go in after. So we've suspended the wooden formers through the boat using our jigs. We tag them into place using small amounts of chop strand in little cut portions, and then we remove the jigs. And then this stringer form, I don't think it's laid up at that point. The stringer form is overlaid. You notice that there's a radius on the top of this stringer. You can probably just sort of make out. The stringers are laid up in a very heavy structural layout that is integral. It starts on the hull, goes over the stringers in one piece and back into the hull again. They're completely encapsulated. Rolling on to another one, please. There's 4 or 5, 1, 2, 3, 4 bulkheads in here. We've now fixed onto the top of the completely encapsulated stringers and bulkheads, we have fitted a foot to receive the bonding area. We're not drilling down into, we're not leaving flat stringers that we drop the wooden deck onto. We're forming a stringer that is separate, and then we put a bonding area back onto the stringer. Are you happy with how that's explained? And you can see this area here is the box chine. Sorry, here is the box chine. Here is a stringer top. And now you can see the deck. This section here is a molded recess in the deck that carries our fuel tank. We don't put a fuel tank in the bottom of the boat and then put a deck on top. That would be somewhat foolish. We put our deck, we have a fuel tank recess, which is a plant on the mold. So when we build the boat, we first of all need to understand what's the engine. Is it a single outboard? Is it 2 outboards? Or is it a diesel inboard? Then we need to retrim the boat. So then we put the load moment through, we work out, we know where the longitudinal center of gravity needs to be because we do our type testing and our development work. So we adjust the position of the fuel tank to put the longitudinal center of gravity back to the right position given the engine specification. The deck is then bonded on the chine, the stringer tops, and a number of other areas and dropped into the boat. And then we overlay back up the flange and onto the top of the deck. So the deck is first of all bonded and then actually laminated into the hull. And it's a structural component. You can see here that there's sections underneath to stiffen, also used to...
Alex was making earlier, sorry.
Thank you, yes please.
Was that you'll find that most other that goes into the hull, they tend to join on top of the flange. So the deck will come from the flange down and across. The problem with that is that usually it's done with a bonding paste, and your tube material attachment strips then cover that area. So even if you've got a break in your bonding, which is quite likely with a hard bonding paste, so you can get a detachment between the 2 layers, you wouldn't be able to see that as a surveyor without taking that attachment strip of the tubes off. Another area to certainly be aware of with a molded deck and molded hull.
Once that deck is put into the boat, can we try the next slide? I don't know if we were at with that. So you can see this changing colour here is where we've actually overlaid onto the deck surface and up and over the flange once it's bonded. So that then becomes the whole hull and deck structure. We happen to then build on the splash well process on the back. If you wouldn't mind just clicking through a couple. Yes, please. And the next, please. So our splash well component comes onto the back of the boat, which is bonded and laminated into the transom. The tube carrier is a complete component. Obviously, that's bringing a lot of stiffening to the back end of the boat, and it's fixed across on the deck as well. So just a bit of an insight.
Yeah, I was just going to go on to this. That's the other thing. So from the boat, open boat, to get the controls from the back of the boat to the console, wiring controls and all that has to go via some kind of conduit system or exposed on deck with a cover over, which is an old version. You'll find that if you haven't got this component at the back of the boat, you've got probably a tube poking out the back of the deck with a load of cables and stuff coming out of it. And you'll find that will fill up with water over a period of time, and the conduits will fill up with water, and then you end up in a situation where your wiring is permanently underwater in foul water as well. So we've seen various boats, we won't elaborate which, with wiring that is in a very sorry state. And you can have the wiring insulation breaking down in the same conduit as a petrol fuel pipe, which again is rubber and doesn't like to be kept in foul water. That's just a point while the picture was there.
So I guess really questions is where we'd probably like to go. Oh, please. No.
Right back in the days when I first started doing it in this manner, I had a few various trials of different bonding materials. Bonded materials, and I tried bonding pastes, I tried all sorts of different things, thickening up resin, etc., epoxies, but I found that actually the best form of laminate to hold that deck in is chopped strand mat. So the rolls of chopped strand mat that it sits on, which sounds a bit antiquated, but actually it's about the strongest method I've found.
Are we going on fairly green?
Oh yeah. They go on wet. Yeah.
But the time between stringers.
Absolutely. So again, this is back to what I was saying about the quality of the laminate. So you're probably all aware that most resins come with a wax additive to make them flow and to lay better. And if you don't get that abraded and laid within 24 hours, you're not getting a good bond. So everything we do, we try and do within that time scale and with good abrasion as well. And touch wood, and the following wind, we haven't had any failures at all. The worst that I've seen in any of my designs are some surface crazing. So again, when you're doing a monocoque deck, one of the things I found in the early days was that you need that structure to be the same as the hull. Otherwise, you're just transferring loading up into the moulding, and you'll get crazing appearing in corners and various areas. Not to the degree that could be structurally failing, but certainly from the perspective of appearance. No one likes to see black star grazing in their white gel pen.
The benefit, of course, of a moulded deck is that during that production cycle, we run from a Gantt planning process. We know that 4 days after we start the hull, we start the deck layer. And they run simultaneously next to each other with the same team of guys working, so that you literally get to the point of finishing the hull in its mould at the same time as the deck finishes on its mould, and you release the deck, turn it over and land it straight in the hull mould where it's bonded and laminated, and the whole thing has happened all at the same landing point, and then you literally pick up the deck and the hull is attached to the bottom, and that's how we release it. Pick the assembly out of the mould. So the assembly process of the hull and deck happens in the hull mould, and it it's timed so that we run from one to the next.
Do you build your own fuel tanks?
We have done. I generally purchase them in. They're 316 stainless, 1.6 mil tanks with a 2 mil tank and baffles. And the tank sits, you can just see the back of the recess here. It drops in. Now, we've been talking about scantlings and structure. So most ribs have their fuel tanks in the hull. They're down under the deck. So how do you get it out? You start with a drill and you start chain drilling until you find something that sounds metallic. Donk. Oh, here we go. So which structures did you drill through to get to the tank? Did we hit the stringers? Did we hit the conduits, the passageways, the bits of drain pipe that people have bogged together with silicon sealant and poked through the decks? Quite feasible you would. The other problem is that once you've completed that process and you've accessed into the tank, we're then dependent upon, or depending upon, another team of inverted commas experts, be they boat builders or surveyors. They've got to replace the stuff that they've removed, the scantlings, the structure of the deck. In this method, where Brian's standing in his shadow, we take the furniture off, we take the screws out of the tank lid, and we knife the sicker flares out. Now, I can say, because I am, boat builders are inherently lazy. If they've taken screws out of a hole, they're quite unlikely to drive nails back through the same hole to replace that lid. The theory being, if you take out a tank lid and you put a tank lid back, you're going to use the same tank lid. You're going to use the same process of reattachment. And actually, therefore, we've covered that process where the average boat repairer doesn't read an ISO from one year to the next because they're damn expensive and they know how to fix a boat, thank you very much. Why would they ever think that they need to go and read an ISO in order to carry out a repair? Well, actually, that simple repair of getting to the fuel tank is a structural modification of the vessel. That's my view of it. It should be simple. In the same way, if you're going to build a boat, put the seats and the console relatively in the same place to each other, so that when you put the cover on, you haven't got to get a cover maker every single time to come out and measure the cover, go away, make a cover, come back, try it on, take a snip out here and sew another bit on. That's, you know, this is a simple analogy for fitting covers, but a lot of boats, when they become bespoke, are actually prototypes. And that's not the route that should be taken for a commercial vessel. My view.
What do you fit into the underside of the deck to attach the seats and the console and everything to?
We use wooden core, so 1088 boom by core throughout the deck. We draw everything that we make. So I don't have a team of lads that make a seat to a lovely scantling, turn it upside down, put a drill bit in the drill, punch some holes through. They have a drawing. The drawing refers to a template. They pop the template over the base of the seat, and they spot the holes in where they need to. Those holes relate specifically or are in position with consideration for the items that are on the deck. So we use wood screws, adhesives, and process to put our seats or furniture into the boat. If that makes sense. Because you must be able to remove the seats again. Even in the build process.
I was going to say, this is a bit of a new point for me, because over the years, again, having a design which had a GRP deck, shiny surface, the idea that I was going to get some chop strand mat and throw it around that flange to hold those seats in was never going to happen. But that was what I was advised at the time. That's the only way that we're going to sign this boat off, is that if these are glassed in with 2 layers, 2 ounce chop. I mean, it's antiquated. It's so far behind. It's ridiculous. So I didn't ever follow that lead. You've got to make sure that the flanges are properly degreased and sanded, and a very good adhesive compound is used with proper length stainless steel screws, and the holes have to be drilled to a particular diameter. Otherwise, the screws aren't going to hold. So I think that's the answer that you're trying to give, is that we screw them to the deck. But in that process, that sounds so, oh no, you just put screws.
If you don't know how thick the deck is, you don't know how long the screw needs to be.
So, when I come along and I say to the person, you got a seat for everybody that's sat in this grid? Yeah, go to seat. So he goes, I've only got 4 seats. I'll add another 3 there at the back. Is that all right?
Pretty much, it depends. Go on, bro.
Well, yes, but the trouble is, are you talking about our boats or are you talking about boats in general? So straight away, boats in general, the answer to that would be no, you can't, because you don't know what the structure is. So unless you've dug a hole in that deck and gone, oh, this is all good, so I can now attach a seat to it. No, you can't. You can't add extra seats to it. Not and be safe in the mind that they're going to stay in the boat.
With ours, you can. We can.
Well, because we know what we've built. You know, that's the whole circle of what we're trying to say here is that
It's too small.
you guys
get inside and have a look.
You guys are on the back foot. You guys are on the back foot. You don't know how that boat's been built. All you can see is a nice shiny surface that someone spent hours cleaning. You don't know what the structure's in.
So really, I think what we would like to get out of it is when a surveyor comes across one of our boats and wants to code it, they give us a ring. We'll have a conversation with you, and you should go away with a warm, cozy feeling, knowing that we've done our job properly. But in the future, you'll be able to come back towards us and say, they want to add 2 more seats. Is that sensible? What testing have you done? Can you show me? How do I know that you built this boat properly? Tell me. Well, we'll show you. Here's our archive file with the last boats we built. Would you like to see the product we put in? Here it is. That was the day we laid this boat. That was the product. This was the man that signed that portion there. And if you don't have a process, laminating sheds are hard to manage.
Well, I was going to say that there's one thing that's been given from day one, and that is that most of the hulls I've built have been white. And most of the hulls have been built with the same gel coat. So over 24 years, I've used pretty much the same gel coat from day one to now. Right. You might say, well, what about the cost? But this is the biggest problem, is that you've got a lot of laminating sheds, even the good ones that are out there, they're using whatever gel they can get cheap. Right. It might be an isotonic, they might have that to tick that box, but it's not going to be the same product. And I think this is one of the things we've made sure of now is that we are using Gaboon ply, we're using the best quality or a very good quality, just a polyester resin, just a general purpose polyester resin, but a really good quality one, and a good quality isotonic gel coat.
And I want to jump onto a completely different subject.
Thank you. When I was at JCB, one of my directors brought in a Mercedes and said, we've had enough of the wiring on these bloody diggers, get it fixed. So we took the Mercedes apart, threw the car away and kept the wiring loom, and spent a long time analysing wiring looms and really understanding how do we get warranty better? How do we get the end user's product better? So I got quite into wiring looms. We build an assembled product. So we were talking about bonding seats in, and the same applies to bonding consoles in. So we make a wiring loom on a board. Most boats, they laminate the console onto the boat, they laminate the seats in, right, batteries. Let's throw them in the seats or in the box at the back. We need to get some cables from the batteries to the switches at the front next. Righto, let's push those wires in. Now we need to run some batteries from the switches at the front to the bilge pumps at the back. Good idea, boys. Hang on, some wires. We'll poke the wires back through the other way. And you spend this time building up a wiring loom. Now, you can buy the best wire in the world. You can buy beautiful tinned copper, marine grade cable. You put one twist in it and give it a little tug, throw it away. It'll work fine for now, but in 4 to 5 years' time, with a bit of motion, where that kink is, you've wasted your time. You've got an unreliable wiring loom and you're going to be chasing down potentially a broken cable somewhere through that system. And it's going to be time consuming. And if you've rodded the cables through, they're going to be wound around each other. So when you pull one, it jams all the others. And we all know these problems, you know, squirting fairy liquid down conduits, trying to pull a cable. At that point, you're stretching all the others. The only solution is the side cutters. Take it off at one end, take it off at the other, and put it in the bin. So we build a wiring loom on a table. We run a wire from peg 1 to peg 6. We give it a number. When we've built the loom, we put the conduits on, the IP67 passageways with the junction boxes with the glands. Then we put the wiring loom as a completed assembly into a console. The console is on a table. We go under it, we stand inside, we have our tools inside the console with us. I know where the cable tie bridges go because there's a drawing. So the guys stand and put in the cable tie bridges to the same positions. They then know that the loom fits into those positions. The loom goes in without being twisted, pushed, pulled, or tweaked. We then test the console. We plug it in, put a battery on the electrical loom, and run everything up. We fit through all the passageways in the boat, the engine looms, the fuel systems, everything else that needs to go in, and we have sub-assemblies in that process. So we're then at the point we have a working console and a working boat, and we haven't jumbled it all through the boat in a final build process. And then the console goes onto the boat, and the one loom that runs aft with battery cables, etc., goes in at the same time. And it's a process is the key.
Just saying there is that actually these aren't groundbreaking things that we're doing. They're just things that are commonplace in a lot of other industries. I think the one thing that we struggle with as a marine industry is this cottage industry, really, and the fact that we have minimal legislation. Maybe the legislation is there, but it's dealt with after. It's a bit like the horse has left and the gate's still open. You know, it would be better, and it'd be better to be introduced right at the beginning. And all these things that we're doing as a way of manufacture, I believe, should be commonplace in the marine industry, not something that's a little bit different. Anyone else?
We're talking about layout versus speed and weight for a minute.
Yep.
So on the same basic boat, presumably you would perhaps offer different engine options. The boat might carry different numbers of people, different weights. It might achieve different speeds with different engine configurations.
Yep.
Presumably that leads to a different layout schedule, does it? Depending on how much you increase or decrease.
No, what we don't do is we don't modify our layout schedule. What we do is we alter our centre of gravity. That's the only thing that varies. The hulls are built strong enough to take the maximum horsepower and weight that we offer. So if, for example, you want a 270 horsepower diesel inboard boat, that will have the same structure scantling other than maybe a couple of extra bulkheads.
Because it has to, because ultimately,
if the structural arrangement different, isn't
absolutely, yes. But generally, the hull skin, the main part, the main two components, so the hull and the deck, are of the same structure. You don't increase that structure because it's got our biggest engine in. So we've got the smallest engine. Let's rewind. Let's say we're going to go with the same boat, but we're only going to put 120 horsepower diesel in it. We're not going to take the structure out of that boat because we could.
Also, the question for people at the front was, if we reduce horsepower, the propulsion size, do we reduce scantling, make the boat lighter?
Yep.
No, because if the engine weighs 400 kilos, that ultimately affects the load capacity of the vessel.
Well, there's a
the
maximum
boat still carries the same weight. The engine is subtracted from the deck cargo weight. So if you have a 90 horsepower engine on the back, the boat won't go very quickly, but boy, will it carry a lot of cargo. Because the stability and the scantling is still worked for that vessel on that side, so we can't possibly reduce scantling to make a lighter boat to go faster. And actually, we need the weight in the boat to make it perform. It's about the hull flats and the form of the boat that we actually, that's the important part. The scantlings have to be adequate for that purpose.
Years to come, maybe change.
Absolutely. There's nothing to say that in 5 years' time, in fact, correctly, 2 years' time, there isn't an outboard on the market that has more than 2-year commercial warranty. So in 2 years' time, it would be assumed that the manufacturer, that the owner would be considering taking off their outboard engines because they're running 6,000 RPM, they're petrol outboard engines. They're not really designed for the commercial marketplace, so the manufacturers give them a very short life in the commercial application. Most businesses would be saying, okay, 2 years warranty, We certainly don't want that engine on for more than 4 years. And I've re-tubed and re-engined one of Brian's boats that he built in 1999, only 6 weeks ago. It's had its second set of tubes and its second engine, and the hull is pristine. In fact, the customer was offered an awful lot more money than he spent on it. And he said, there's no way I'm selling it, because I can't buy another one. So,
Think about changing engines from 2 strokes to 4 strokes.
great idea.
But that was when.
Except for the weight for that.
Do you know what that was? That was about the time I started. So in '96, in the same area there was a company called Bridtech. If any of you guys remember that company, and they had done all their designs based on 2 strokes. Of course, suddenly 2 strokes were outlawed and 4 strokes were the thing, but ever so much heavier. So they struggled with their centre of balance because they'd set everything up and achieved a reasonable ride based on 2-stroke engine. And suddenly they're having to consider the fact that they've got extra 100 kilos out on the back of the boat.
You're thinking about that naturally, I think, from the builder's perspective. I'm thinking about it more from the surveyor's perspective.
Right, yes.
Looking at a boat that might have been built originally with a 60 horsepower.
Yeah, but
and then someone has come along later and put a 60 horsepower.
to be fair,
without changing anything else.
Absolutely, but to be fair, I think that that would have been probably, if it was designed to suit a 2-stroke, it would have been designed and built probably mid-90s. So chances are you wouldn't want to be putting that boat to sea.
And also, the builder's plate has a provision for that. It shows you clearly engine plus people plus your suitcase, cargo, equals boom. It's always recorded in an outboard power vessel. The load includes the outboard engine, so it is the surveyor's responsibility to know that's a Yamaha or a Suzuki. That Suzuki 200 weighs 347 kilos. I've got a brain injury and I can remember it. It's all available, the information is there. The builder's plate covers this, in my view. It's there. Something I didn't mention, sorry to be diverse, is that to scattergun, but I don't think I've mentioned any of our clients. We're the supplier for the British Antarctic Survey. We won our first proper tendering process, all in-house, was to the British Antarctic Survey. We build boats for, as example, Williams Shipping up in the top of Southampton Water. They use our room. Antarctic Survey. We have a number of local photographers, a number of classic yachts, and a couple of, a lot of our customer base seems to come from yachting fraternity as well. So,
earlier on you touched on shock mitigation seating.
Yeah.
Back in 2010, 2011, there was a move from the conventional sort of pillion and bench seat arrangements over to things like Scott seats and Coleman. Did that produce any challenges for you as designers and builders fitting that type of seat?
Yeah,
different types of loading.
Yeah, a lack of understanding. I don't sell shock mitigating seats. I sell springy seats. If you make a seat and you incorporate into the seat a moped spring, what you've built is a springy seat. The very simple principles of the mechanisms in some of the seats that are available are fundamentally wrong from an engineering point of view. I.e., when you compress the seat, the 2 pivot points between the spring and the hinge become closer, therefore the body weight gains momentum over the spring. You gain mechanical advantage over the spring. It's completely inverted. The seat should work the other way up. There's all sorts of curious shock mitigating systems and seats where actually the emphasis should be put into hull form and stability and performance. And the ultimate shock mitigator is that lever that should be on the dashboard of the boat. How you trim the boat, whether you've put the helmsman and the weight on the right side so that that hull, in its correct form, lands upright into the water that it's presenting. If that lands like this, no shock mitigating seat that's moving in that aspect is going to serve you any purpose whatsoever. And do you know what? The MCA can't categorise the seas that we're going to meet. The RCD haven't managed to come up with a proper You know, we're still debating whether or not we see mega waves. We can measure the sea height to within 2 or 3 mil with a satellite and predict tidal flow, but we still don't really understand what you're going to meet outside Cowes on a Friday afternoon when you've just popped out between cups of coffee to take a few photos in your jeans and t-shirt. We've done it. We know what it's like. You know, shock mitigating. I think it's really interesting. That I think there are some great seats on the market. Genuinely, I think there's some really interesting development work going on. My view is, if you're going to have a shock mitigating seat, if you're on a ship, you have a proper shock mitigating seat. Your feet don't touch the floor. These knees are pretty knackered, but they take an awful lot of shock out. That can't work if you've got a spring between your legs. If you're sat on a seat and your feet are on the floor, how do we know where the proportion of weight is going to be? How many of these people who are designing and selling, talking about shock mitigating seats, are going out and measuring the shocks that they're experiencing? We did. We found a little data logger that lives inside a lot of shipping containers, and it records acceleration in 5-axis for 12 months. So we changed the algorithm, changed the device. It records in a shorter time period. Some of the shock is incredible. Some of the shock loading is absolutely remarkable. Very hard to come up with any information that we could do anything with there, so we gave up. We build a springy seat.
Sorry, what do you actually do with your seat? Basically, you know.
I'll show you. Got a picture here. We purchase a mechanism from a manufacturer, and we build. Excuse me, those will bring it around. Got a few bits in it. We use a purchased mechanism here, which goes up and down. The more interesting stuff is the seat on top. Does it give you lateral support? Can you stand over it so that you can get your bum off the seat quickly if you see a big wave? And can we still store a battery in the right place? And can you walk between the seats? Can you move from the center position of the boat forwards and backwards and get around the deck in a little workboat? Too often the seats don't have sufficient backrests. They have nice shiny handles and lots of stitching that allows the water through the fabric, but they don't actually configure themselves to where the seat needs to be in the boat and give the support. I'll leave the book to
Request from the guys online. Could they have a look at the photo, please, in front of the camera?
Yes, I will bring it around now. It's just passing around the.
We've got 2 or 3 minutes left.
Yes. Perhaps so.
You and I spoke about the importance of standards, the importance of quality, all of those things that, you know, surveyors were troubled with sometimes, you know, always wanting to perform at the highest level, safety of life at sea, all of those things. So a couple of minutes maybe just to say, you know, what advice can you give surveyors from your perspective? Because I know you're passionate about this stuff.
It's a difficult one. There must be subjective assessment. You have to stand back at it, back from it, look at it, and say, is that boat fit for purpose? That has to be the starting point, doesn't it? As I say, if I'm going sailing, I'm less concerned about the life raft than I am about the boat that I'm getting on to start with. I want to know the boat I'm on is going to work and look after me. The process of emergency management afterwards is a separate issue. So, boat has to be safe to start with. The people need to be in the right places. The decks need to be in the right configuration, and a surveyor must get a warm and cosy feeling from the boat builder that they engage with when they start to ask the questions about structures, scantlings. Give me a clue, guys, what have you done? What's inside the monocoque, and do you understand what you're building? Is really where I would like to see it coming from. I would love surveyors to test us more and provide me with the information and say, this is what you need to do. Can you prove that you've done it? Rather than the question more being yeah, where do you keep your life jackets? Yeah, genuinely, that you should be able to look at the boat and have an understanding of the seaworthiness. That's, to me, a really important factor. Really interesting to stand and talk to mums at a recreational boat show where they're saying to me, I don't want that boat because it's not recreational enough, not safe for my children. And actually, in a 2 or 3 minute conversation, and in my mind at the moment, I can see the lady I was talking to. She came on Wednesday, the family returned on Sunday and purchased the boat. And actually, it's because we don't do what we're told, if you know what I mean. We actually put our efforts into things like developing a polycarbonate windscreen, so that should it go wrong for you, it doesn't shatter.